everybody. We are going to discuss simple harmonic motion. I am Srinivasa Charyulu. Simple harmonic motion, generally speaking, if a body is in motion, when its acceleration is directly proportional to its displacement, taken in opposite direction, then we can say the body's motion as simple harmonic by nature. Now, by looking to this one, you can understand directly that acceleration is equal to omega square multiplied by displacement. Omega square is going to be the constant of proportionality in this particular case. When I take only the magnitude of this one, omega can be written as under root acceleration by displacement. This in fact is the basic equation one should remember as far as simple harmonic motion that is concerned. What is this omega called? In fact, it is called angular velocity. But in this particular chapter, we can even call this one as angular frequency. That is actually the name what we people used to give to this. When omega is equal to acceleration by displacement taken under root, automatically the linear frequency part of it, which is omega by 2 pi, that now becomes 1 by 2 pi under root acceleration by displacement. So this is the frequency equation for a particle or a body which is in simple harmonic motion. If you just take the time period corresponding to that, frequency's reciprocal value is time period. Thereby this now becomes 2 pi times root of displacement by acceleration. In fact, simple pendulum comes into the same concept. A loaded spring which is oscillating vertically up and down, that also can be taken or explained in terms of simple harmonic motion. So basically these three equations one should remember before going to the problems part of that. That's one. Come to the next aspect please. Which equation that gives you harmonic motion in brief? When we talk about simple harmonic motion, this can be explained either in terms of a sine function or in terms of a cos function. What for also you can understand directly in trigonometry, sine and cos functions, we generally call them as harmonic functions over here. Thereby, sine function or cos function is going to be taken up while writing the equations representing simple harmonic motion of a body. But when to take sine function and when to take cos function? For example, if you look at a pendulum which is oscillating, the oscillations of the pendulum can be taken up in many ways in fact. I can start the oscillation from the mean position of rest, it goes towards my right, comes back to mean position, goes towards my left and again comes back to mean position. Suppose if the oscillation is counted starting from mean position of rest, then we opt for sine functional equation for that. If I continue the oscillation or if I count the oscillation from extreme to extreme, that is from right extreme to left extreme, half the oscillation, from left to right once again is one complete oscillation over here. If at all you are going or measuring that particular oscillation from extreme position, then it can be taken in terms of cos function. So overall, before taking up the problems, you need to remember if displacement equation is taken as y is equal to a sine omega t, a being amplitude, sine being function and omega t being the phase over there, then velocity can be written as a omega cos omega t. By differentiating this one with respect to time, we will get this equation. Acceleration, of course, we will be getting that one as minus a omega square sine omega t. Once again, by differentiating v with respect to time, we get this equation. So these three equations are also to be remembered before going to the modals. Coming to the next one, what is the velocity of a particle in SHM? Omega root a square minus y square we people used to write. Y being the displacement here and omega a being the amplitude. Amplitude is nothing other than maximum displacement of the particle. So if you take velocity is this much, then what will be acceleration of a particle in SHM? Omega square y, y being the displacement here. Suppose if I write half mv square, taking this v as velocity, I will be getting the corresponding kinetic energy. Therefrom, I can even attain the potential energy of SHM also. So, these are the basic concepts before taking up the models you need to remember. So, taking these things into consideration, let us work out few problems based on this particular chapter. So, let us take the very first number over here. A particle starts its simple harmonic motion from mean position at t is equal to 0. If its time period is capital T and amplitude is capital A, then the distance travelled by the particle in the time from t is equal to 0 to t is equal to 5t by 4. That is the concept. That of course you people can understand taking an example of a simple pendulum. T is equal to 0. Total time period is given capital T. Time period means what? It goes there, comes back, goes there and again coming back like this. That means starting from mean position going to the right extreme, coming back to mean position going to left extreme, coming back to mean position. This covers one complete oscillation and the time taken by this for this particular complete oscillation is given as capital T in the problem. So, what you should understand is to go there, it takes t by 4 time. Again to come back to mean position, t by 4 time. To go to extreme left position, that is t by 4 again, and coming back to mean position, t by 4. So, one complete oscillation means total time will be t. We have taken that one into 4 equal parts like each one t by 4. But question is given in 5t by 4. Already 4t by 4 is over. Once again it has to go there, that means in t by 4 seconds. All of you can understand each time it covers the maximum displacement called amplitude. If I take the amplitude as a here, coming back one more a, going there again a, coming back a and going to this extreme a. So 5t by 4 is nothing other than 5 times the amplitude, because 1/4 the oscillation means that is totally speaking the distance covered over there is maximum and it's called amplitude. So what should be your answer over here? The fourth option is the correct option for that. That should now be 5a, that is the total distance travelled by the particle when it has just completed a time of 5t by 4. That is the concept. Now come to the second problem please. If you just look at that one, if the displacement x and velocity v of a particle executing SHM are related through the expression 4v square is equal to 25 minus x square, then its maximum displacement is how much? In fact, by definition every one of you know, maximum displacement itself is called amplitude. Just now I have reminded you before taking the problems. Velocity of a particle in SHM can be written as omega root a square minus y square or a square minus x square, whichever you talk about, that x or y that represents the displacement, a represents maximum displacement which is called amplitude. Now what is the equation given? We see, you see rather 4v square is equal to 25 into or 25 minus x square. That is the equation given. So let us write first of all v square is equal to 1 by 4 times 25 minus x square I can write. This v now can be written as 1 by 2 root of 5 square minus x square I can write. In fact that 25 can be written 5 square. Just compare this equation with the original formula what is known to all of us. So here it omega, here is half. That means what? Angular frequency of that body or the particle which is in SHM is going to be 1 by 2. Very clear. Here a represents amplitude. What do you have in place of a now? It is 5. Therefore, amplitude which is maximum displacement, that is what has been asked, that is now going to be 5 units. That in the sense if everything is given in meters by any chance, directly you can write 5 meter. If suppose the unit is given in centimeter, 5 centimeter, whatever it is, maximum displacement is nothing other than amplitude. In place of A you have 5, therefore your option automatically becomes 5 meter over there. That is option number 3. Now look at the next number, that is problem number 3. A horizontal platform is executing SHM up and down with a time period of 1 second. The maximum amplitude with which it can vibrate so that a small object placed on the platform does not leave its surface is how much? Here, for simplification of the equation or the calculation, pi square is equal to g. He has given us, take pi square as g wherever you come across pi square like. So that is actually the concept. But look at carefully, first of all, a platform when we consider. When you are placing a body and the platform is oscillating vertically up and down like, certainly there is a possibility for this body to jump or it may leave from that particular position of rest. But according to this problem, a small object placed on the platform does not leave its surface. That should be the condition there. Does not leave its surface means the weight over here that is acting on the body, that now must be equal to mr omega square. What is this r now called? It should be called as amplitude of oscillation or vibration of the body. Now according to the given problem, mass of course gets cancelled. You can write g is equal to r times omega square 4 pi square by t square. That is actually the formula. But of course a time period is given as 1 second. Then automatically t square will be 1 square, that will again be 1 only. So you need not take this one. Now what is the question that is asked? What is amplitude? The amplitude in this formula is represented by r. I now can write that one as 4 pi square in the denominator, g in the numerator, g by 4 pi square. But of course given very clearly in the problem, pi square and g are numerically equal, he said, as far as the values are concerned. Then automatically 1 by 4 will be left. What will be this value? 0.25. What exactly are the units over there? If it is taken in SI units directly once again, you can say that 0.25 meter must now be the corresponding value. So what should be the correct option for us for this problem? It is the very first option, that's 0.25 meter, which is the correct answer for us. That is for problem number 3. Let us now check the very next problem, that is problem number 4. The time period of a particle in SHM is 8 seconds. Yet t is equal to 0, it is at the mean position. That means it is starting from rest, it is understood. The ratio of distances travelled by it in the first and second seconds is how much? All of you should understand the wording thoroughly. First second and second second. That means it is a particular period of time, not in 1 second, 2 seconds like. 2 seconds, suppose if they give, it is understood 1 plus 1, that is 2 seconds total. It is a second, that means after the first second has been lapsed, before the third second, what is the distance travelled exactly in the second? That is actually the concept what has been asked. So you can directly understand t is equal to 0, it is at mean position. Mean position means what you can understand? Y is equal to a sin omega t 2 pi by capital T into small t equation I can write for SHM of the particle. Why sine function means, already I have briefed you in the beginning that the particle is starting from the origin, that is rest position. Rest position means sine function is to be taken, extreme position means cos function to be taken, that is the concept. Now when you talk of this 2 pi by t into t, what is the displacement in first second? Let us write this one. Now that I write it as y1, a I take it as it is, right? And of course SHM he has given the time period as 8 directly. Sine you can take up 2 pi by capital T, that is 8, into small t is 1 second. It's after 1 second, first second, that's the concept. Now you can cut this one over here 4 times. Pi by 4, sine of pi by 4, that's sine 45, 1 by root 2, a by root 2. I will be getting the distance. Now in 2 2 seconds, what is the displacement? I calculate y. I call this one as y dash. In 2 seconds means how to write this one? A sine 2 pi by 8 once again. This time in place of small t, I should write 2. Now 2 into 2 becoming 4, that goes twice. Sine pi by 2, sine 90 being 1, you will be getting it as A. But if you look at the question carefully, first and second means y2. Suppose if I want, how do I get? It is y dash minus y1. That means this is the distance travelled in 2 seconds. This is the distance travelled in 1 second. I just want distance travelled by the body in the second only. That means y dash minus y1. Y dash being a, y1 being a by root 2. Then what will you get? Root 2 minus 1 by root 2 into a. That will now be the value of y2. Now the question that is given over here is, what is y1 by y2? That is the question. y1 is the distance travelled in the first second. y2 is the distance travelled in the second now. What is that ratio? A by root 2, directly you can write in the numerator, by, what is this value? A by root 2 into root 2 minus 1. This a by root 2 getting cancelled. What will now be left over? 1 by root 2 minus 1. That now will be the corresponding ratio. 1 by root 2 minus 1, if you just look at, the concept is the third option which is going to be tallied over there. That is the correct option for this problem number 4. So 1 by root 2 minus 1. But one should read the question carefully, because it is not in 1 second, 2 seconds like, it is in the first and second seconds. That is important point to be noted here. Now check the next problem, problem number 5 please. A body executing SHM has a maximum velocity of 1 meter per second and maximum acceleration of 4 meter per second square. Its amplitude is how much? In fact, when a particle is in simple harmonic motion, its maximum velocity, we can represent it by the formula A omega. A being amplitude and omega being angular frequency of the body. Exactly in the same manner, maximum acceleration can be represented by A omega square. Once again, A is amplitude and omega is angular frequency. Now the question is, this value is given as 1 meter per second and this value is given as 4 meter per second square. What is amplitude? The question. Amplitude in fact is maximum velocity square by maximum acceleration. This is the direct formula if you can remember. Otherwise also you can do it. Look at, for example, V maximum square in the numerator I have written. A square omega square divided by A maximum A omega square. Omega square cancels, A square by A, that again becomes A. So is it not amplitude here? So V maximum square, it is 1 square, that is 1. By, what is this value? A maximum, that is 4. 1 by 4, it is again going to be 0.25. What? Meter is going to be the corresponding amplitude. So whenever they ask you amplitude value, directly if you can remember this formula, you can save your time and calculation as well. So 0.25 meter, which is the fourth option, that is a correct option for this question number 5. Now let us check the next number please, that is problem 6. Y is equal to 0.05 sine 2 pi into 0.1x plus 2t. Represents a wave equation in which distances are measured in meter and time in second. That means every value he has given in SI units. Then the wave velocity will be how much? Particle velocity already we have discussed, omega root a square minus y square. What is the general formula for wave velocity please? Wave velocity is n lambda. N being linear frequency and lambda being wavelength. Now what is the value? The equation given, you see carefully. 0.05, that becomes the amplitude. Sine, multiply the whole thing by 2 pi. 2 pi into 0.1 into x. That is what has been given. Plus 2 into 2 pi, that is 4 pi into t. This is the given equation. If you just go to the original equation, what we people is to write for a progressive wave in general, y is equal to a sine 2 pi by lambda into x plus 2 pi by capital T into small t. This is the original equation to be remembered. This is given equation and this one is a known equation for all of us for SHM. Now simply compare them. In place of 2 pi by lambda, what do you have here? 2 pi by lambda in the original equation is equal to 2 pi into 0.1. Now 2 pi getting cancelled. What will you get? Lambda is equal to 1 by 0.1. That is going to be how much now? 10 meter. That is the value of lambda. Now come to the next one, 2 pi by t, that also can be written as 2 pi n. 2 pi n is equal to given as 4 pi. Now pi getting cancelled here, 2 gets cancelled twice. So what will be the value of n here now? 2 what? Heads. That is the unit for that. Now n is 2 and lambda wavelength is 10 meter. What is velocity formula? N lambda. So 2 times 10 now becomes 20 meter per second. So if you look at the options carefully, the second option is going to be the corresponding answer for this question number 6. 20 meter per second is the corresponding answer for that. Let us now check the next number. Problem number 7. The time period of oscillation of a particle in SHM is pi second. If its acceleration at extreme position is 1 meter per second square, its velocity while crossing the mean position is how much? One thing one should understand, whenever a particle is oscillating simple harmonically or vibrating simple harmonically, at extreme right or left, the body is going to have maximum value of acceleration. While crossing the mean position of rest, it will be having maximum value of velocity. So what is the value given here? You see, if its acceleration at extreme position is 1 meter per second square, acceleration at extreme position is also called as maximum acceleration. What is its formula officially? If I write maximum acceleration, a omega square is the formula and its value is mentioned as 1 meter per second square. That is the concept. Now when you talk about a omega square is 1 meter per second square, what is the other value given? Time period is given pi seconds. Now come on, expand this one. A into 4 pi square by t square, that is equivalent to 1. Because omega can be written 2 pi by t in terms of time period. So 4 pi square by t square in place of omega square I directly can write. Now what is the t value here? T square is pi, because t is given pi means t square will be pi square. These two they get cancelled. Then what will be the amplitude you are getting? 1 by 4 meter. That will be the amplitude. Now what exactly is the value we want? What is maximum velocity is the question. Maximum velocity a omega we can write 1 by 4 times. What is the value of 2 omega? 2 pi by t. T in the sense once again it is pi. Pi getting cancelled. It is now going to be half. Half in the sense what will be the value here? 0.5 meter per second. This is of course one method of doing the problem. Same question you can even write it in a different manner also, further simplifying this one. A omega square is given. Can't you write a omega square as a omega into omega, that's value is given 1. Now I just want the value of a omega. What is that value now? 1 by omega. 1 by omega is 2 pi by t. Therefore, t by 2 pi. T and pi are equal. They get cancelled. 1 by 2 again. Once again you people are getting 0.5. So 0.5 meter per second. Whether you go by this method or a direct method, whatever it is, the ultimate answer that tallies over here is the first option. That's 0.5 meter per second as such. That is velocity maximum. Come on, let us take the next number, that is problem number 8. The displacement of a particle executing SHM is given by y is equal to 10 sine 6t plus pi by 3 meter. Here time is taken in second. The initial displacement and the velocity of the particle are what? One thing we should understand the wording here carefully. Initial displacement. When time is equal to 0, whatever be the value of y you are getting, that itself is called initial displacement. This is actually the concept. So what is the equation that has been mentioned over there, please? Y is equal to 10 in place of A. He has directly given you the value of 10 sine. What is the value of phase that has been mentioned there? 6t plus pi by 3. This is the given equation. Now when t, you put it that one as 0. T0 means then only the displacement is called initial value. Therefore, when you put T0, if t is equal to 0, then what happens to y? 10 sine pi by 3 you get, because 60 gets cancelled. Sine pi by 3 being 60, sine 60 is root 3 by 2. You can write 10 root 3 by 2. That now becomes 5 root 3, what? Meter. That is corresponding displacement over there. That too initial displacement. Now what next is asking you? What is velocity? Velocity is equal to omega root a square minus y square. That is actually the formula. Omega, that is 2 pi by capital T. We can understand that one. What is that value of omega given in this problem directly? 6. Root of a square, 10 square 100, minus displacement square, 5 root 3 whole square, which now becomes 75. Root 100 minus 75 now becomes root 25, which becomes 5. 5 into 6, 30 meter per second will now be the corresponding velocity. So what are the two options? They are correct over here. Fourth option, if you look at 5 root 3 meter is the initial displacement and 30 meter per second is going to be the corresponding velocity of the particle as such. So fourth option is the correct option for this problem number 8. Now let us check the next number, that is problem 9. A particle moves such that its acceleration is given by a is equal to minus b into x minus 2. Here b is a positive constant and x is its position from the origin. The time period of its oscillation will be how much? That is the concept. But in fact we know, according to the concepts of simple harmonic motion, acceleration is equal to minus omega square y. That is the equation. A for acceleration here and y for displacement over here. Now look at the equation what has been given to you. A is equal to minus b into x minus 2. This is the value given. So if you look at carefully, here omega square and here b are supposed to be equal numerically. So we can write omega square is equal to b. But what is omega square? 4 pi square by t square is equal to b. Then what will be t square, please? 4 pi square by b. Then what will be the time period? That is the question. It is now to be taken 2 pi under root 1 by b. That is actually the concept, root of 4 pi square by b. 4 pi square under root is 2 pi. 1 by root b, that only I am writing it this way. 2 pi root 1 by b. This is the corresponding period of time, which is coinciding with the second option over there, that is 2 pi under root 1 by b. So this is the method we people used to adopt whenever they give an equation for acceleration of the body as such. That is the point. Now look at the next problem, please. That is problem number 10. If you look at the one, what a particle executes SHM along a straight line 4 centimeter long. When the displacement is 1 centimeter, its velocity and acceleration are numerically equal. The time period of the particle's simple harmonic motion is how much? That is the concept. One thing you should understand, 4 centimeter long, that is what has been given. 4 centimeter long means you should understand that 2 centimeter on either sides the body used to oscillate. This being the mean position of rest. So what you should understand, this should be 0, this side 2 and that side 2. So what will be the amplitude that is given over here? That now will be 2 centimeter. That is the meaning of giving you 4 centimeter long path. That is the concept. And of course, what else he has given you? Displacement is given 1 centimeter as such. That is the concept. Its velocity and acceleration are numerically equal. That is the concept. What is velocity, please? Omega root a square minus y square. That is the formula. When you talk about this one, omega, you write it as it is. Root of a square now will be 4. Y square now will be 1. Is it not simply root 3 times omega, please? This is actually velocity what has been given to you. And what will be the acceleration? Omega square y. What is y value we know? So is it not simply omega square, please? So velocity is root 3 omega and acceleration is omega square when y is equal to 1 centimeter. According to the given problem, these two values are numerically equal. That is what has been concluded in the problem. Come on, equate them now. Root 3 times omega is equal to omega square. 1 omega gets cancelled. What is the concept he is asking you for? Time period is how much? So root 3 is equal to 2 pi by capital T. We just want the value of capital T now. Is it not 2 pi by root 3, please? So what will be the corresponding time period? When velocity and acceleration are equal, at displacement is 1 centimeter. 2 pi by root 3 seconds. Of course, if you look at all the 4 options, 2 pi by root 3 coincides with the very second option over there. That is why the second answer is the correct option for this one. That is problem number 10. Let us now check the very next problem, please. Problem number 11. The ratio of amplitudes of the simple harmonic oscillations given by y1 is equal to a sin omega t, that is one equation, and y2 is equal to a by 2 sin omega t plus a by 2 cos omega t is how much? Amplitude he is asking, that to ratio he is asking. Let us check first equation first. A sin omega t, y1 is equal to a sin omega t. Very clearly speaking, this is the corresponding amplitude. For that, no calculation that is needed for that. What about y2 that has been mentioned over here? It is a by 2 sin omega t plus a by 2 cos omega t. This is the equation 2 that is given. Then what will be the resultant acceleration of this part? It is root of a1 square plus a2 square. a1 square plus a2 square means what is a1 here? A by 2. What is a2 here? A by 2. A by 2 whole square plus a by 2 whole square. Is it not a by 2 root 2, please? You can write the same thing this way also. It is a by root 2 as such. So what will be a1 according to the first equation, please? It is a. What will be a2 according to the second equation now? A by root 2. What is the ratio of a1 to a2? That is the question asked. So a by root 2. Now a getting cancelled, what is now left over? Root 2. Root 2 means in fact it is root 2 is to 1. Which option that is correct over there? You once again guess that one. Fourth option is the correct option for this problem number 11. So that is the concept you people have to take up. So whenever an equation like this is given, taking a1 square plus a2 square under root, you will be getting the corresponding amplitude there. That is question number 11. Let us check the next number, that is problem number 12, please. What is that problem given? Once again, let us see. The displacements of two particles of same mass executing simple harmonic motion are represented by the equations x1 is equal to 4 sin 10t plus pi by 6. Let us write that equation first. x1 is equal to 4 sin 10t, right, plus pi by 6. That is actually the additional phase here. This is the concept. Now what about the second equation? x2 is equal to, what is that value given? 5 cos omega t. That is the actual equation given. Now what is the question that is asked? The value of omega for which the energy of both the particles remains the same. Energies are going to be equal. Means what? Energy equation generally when we take half m omega square a square. This is the formula. Half m omega square a square, that is the total energy of a particle in a SHM. Out of that, half is constant, we know. M is constant, we know. Here if at all there are any variables like omega is a variable and A is a variable. When their energies are equal, omega 1 square A1 square can be equated to omega 2 square A2 square. This is the actual equation we can write. In other words, you can write like this also. Omega 1 A1 is equal to omega 2 A2. That is the corresponding value. Now, if you look at carefully, omega 1 by A1 is equal to omega 2 by A2. What is omega 1 given here? Look at that one as 10. What is A1 that is given over here? It is 4. So, you can write 10 times 4. Okay, if you directly take it also 10 square into 4 square, you can write over here, there is nothing wrong. If you take the original equation itself without taking root and all, 10 square into 4 square like, that is equal to, what is omega 2 square? I don't know, because it is given as omega only. What is A2 square? That now becomes 25. So what happens here now? 4 square, it is 16 times 100. By 25, that now is equal to omega 2 square. This goes 4 times. So what will be the value of omega 2 now? It will now be root of 64, which now is going to be 8. What? 8 units like you can write. That of course either radian per second you may be given there or radian per minute, whatever it is, nothing has been mentioned, therefore we people are writing simply corresponding units there. So what is the correct option there? It is a 8 units, means the fourth option is going to be the correct option for this question number 12. Let us now check the very next problem, that is problem number 13. The displacement of a particle executing SHM is given by y is equal to 5 sine 4t plus pi by 5. If t is the time period and mass of the particle is 2 gram, the kinetic energy of the particle when t is equal to t by 4 is given by. This same question has been asked in one of the EAMCET papers in recent years. So one thing you should understand, first of all, y is equal to, it is given 5 as the amplitude, sine 4t, that of course is inside the brackets, plus pi by 5, that is what has been given first. And what is given there? T is the time period and mass of the particle is given 2 gram. Kinetic energy after small t is equal to t by 4. Here, can't you understand, omega is given as 4. Omega is officially 2 pi by capital T, we know that one very well. Then what will be the time period now, please? It is 2 pi by 4, which now becomes pi by 2 second. This is the value of time period. So you should understand first of all what is the corresponding time period. Come on, let us now take what is small t given in the problem, please. In the problem, what is small t that is given? T by 4 it is given. So first of all, rewrite this equation. Y is equal to 5 sine. What is this 4t? 4 into t by 4. Okay? Plus pi by 5, whatever we people are having here. That is the concept. Now if you look at 4 gets cancelled, directly you will be getting sine 5 sine. What is this value of capital T? Already we have got it here, pi by 2. Plus this now is pi by 5 like. But officially the problem it is to be given here as pi by 3. That is actually the concept here. So what we should write in this particular case is, if it is pi by 3 like, you will be getting 90 plus pi by 3. That now becomes 5 cos pi by 3. That in the sense, what is this value now? You will be getting directly the value 5 cos pi by 3, cos 60 by 2, it is now 2.5. So what will be the corresponding displacement over here now? 2.5 meter as such, that is one aspect. When it is the case, what is this question officially? Question is not this displacement or something. What is its kinetic energy? Kinetic energy is what? Half m omega square into a square. That is the total value of kinetic energy. So if you directly take up that value, what is this A square? Displacement is this much, means half m omega square into A square minus y square we used to take. If it is a maximum kinetic energy, y square of course need not be taken because y will be 0. But here he is not giving you the word as maximum, so we need to write it like this. Now half into, what is the mass value that has been mentioned? It is 2 gram. 2 into 10 to the power minus 3 kg. Omega square, of course you can definitely understand it is nothing other than 4 pi square by t square. That is actually the concept. And of course we know what is A square minus y square. A being 5, here we can write directly 5, and y being this 2.5. Come on, just substituting those values over here. Whatever the kinetic energy we people are getting, that exactly coincides with nearly 0.3 joule. That is the corresponding equation what we people used to get. That is the fourth option that's going to be correct over here for question number 13. Right? Now look at the next problem please. That is problem number 14. A particle is executing SHM with an amplitude A and time period t. The displacement of the particle after a time 2t from its initial position is how much? That is the concept. Sometimes very simple questions of this kind also can be expected in final EAMCET exam. Generally this is a question. Time period is capital T. What do you mean by that? If I take for example a pendulum, like it is just going there, coming back, going this side and coming back, the time taken is going to be T. That means in one complete time period, is not the body coming back to the same position of rest please? That means what you should understand, when one complete oscillation is made, then the displacement of that particular body is going to be 0. That is the concept you have to understand. So for every time period t, the body's displacement will be 0. Now here the question asked is the displacement of the particle after a time 2t. 2t means what? 1t it is coming back to rest. Again after t seconds it comes back to rest only. That means once again the displacement will be 0. But one should remember here, the answer for this 14th question no doubt is going to be 0, the fourth option. But there is a slight confusion here. If you are not understanding the word displacement carefully, there is a possibility for you to put the option as the third option as well, 8a, because it is going there to a distance, again a, this side a, this side a. One complete oscillation means for a distance it is traveling. 2t's time means 8a distance it can travel. So 8a also can be your answer if that fellow asks you what is the distance traveled in 2t seconds. But in this case he is asking you displacement, therefore 8a will not be your answer. Displacement should now be 0. That is fourth option, which is the correct option for us. That is the point you have to remember. Now come to problem number 15, the very next number over here. If you look at that one, the kinetic energy of a particle in SHM is 8 joule at its mean position. If its mass is 4 kg and amplitude is 1 meter, then its time period would be how much? Kinetic energy at its mean position is 8 joule. Kinetic energy at its mean position means what? Maximum kinetic energy half m omega square a square. This is given 8 joule according to the problem. Now what are the other values given? You see there, half, mass is given 4 kg. And what is the value of amplitude that is given over here? Amplitude is given 1 meter. Amplitude square becomes 1 meter square is 1 into omega square is going to be 8. Now of course this goes twice. So omega square now becomes 4 and omega automatically becomes 2. But his question is what is the time period? Omega can be written as 2 pi by capital T. Then what will be the capital T over here? 2 pi by 2. 2 getting cancelled, you are left with pi seconds. So what will be the corresponding time period of the body is the question. It will now be exactly pi seconds. That means the very first option that's going to be correct over here. Now look at the next number 16, a different model question altogether. the potential energy of a simple harmonic oscillator of mass 2 kg at its mean position is 5 joule. If its total energy is 9 joule and its amplitude is 0.01 meter, then its time period would be how much? That is the question. If you look at, first of all, mean position he is talking. So potential energy at the mean position is given 5 joule. But at the same time, total energy that is given 9 joule. So if you can take up potential energy plus half kx square of that oscillator, that now must be equal to the total energy over here. That means energy total now can be equated to potential energy plus half kx square. Then what will be the value of half kx square from this one? Total energy 9 minus 5, which now is going to be 4 joule. That is the corresponding value. Then what will be this value of K? K is called force constant of the oscillator, or spring constant also we can call it. So 2 times 4 by x square. What is x that is given? 0.01. I write that one as 10 power minus 2 whole square. That is 10 power minus 4. Then what will be this value ultimately? 8 into 10 to the power 4. This is actually Newton per meter. That is the corresponding unit for K. Fine. Now K value, if you know, what is the time period of an oscillator? 2 pi root m by K. That is the formula for time period. What is mass that has been given over here? 2 kg. And what is the value of K that we have got? 8 into 10 to the power 4. Now this goes 4 times. You will be left with 2 pi by root 4 is 200. So this goes exactly 100 times. And what is the total value you are getting now? 100 by pi by 100. That is actually in terms of time, that is second, is going to be the time period. So which option is correct over there? Once again, the very first option, pi by 100 second, is the correct option for this question number 16. Right? Now let us go to the next number, that is problem number 17. The displacement of a particle in SHM is given by the equation y is equal to 10 sin 8t plus pi by 3, where y is in meter and t is in second. Its velocity when its displacement is 6 meter is direct application of the formula. In fact, all of you know pretty well velocity by this time, already you are all familiar with omega root a square minus y square. That is the formula for velocity. What is the value of omega from the given equation, please? Omega is given as 8 because 8t it is given in the equation. 8t means that 8 becomes omega into root of what is amplitude? 10 square 100 minus what is the displacement given? 6 meter, 6 square, which is 36. Now 8 times root 64. Root 64 again is 8. 8 into 8, 64. What? The corresponding value, if you take in meter per second in SI units, the velocity of that particular particle at a displacement of 6 meter from the mean position, that is going to be 64 meter per second, which is coinciding with the fourth option of this particular question number 17. So 64 meter per second is the fourth option which is going to be correct for this question 17. Let us now check the very next problem, please. Problem number 18. The displacement from mean position at which the kinetic and potential energies of a particle in SHM are equal if its amplitude is A. Obviously, kinetic energy and potential energy, their magnitudes are to be equal according to the problem given. What is kinetic energy formula? Half m omega square into a square minus y square. This is the kinetic energy formula. That now should be equal to what? Potential energy. That is half m omega square y square. That is the corresponding formula for potential energy. Yet what amplitude or displacement in this particular case, kinetic and potential energies are equal? That is the question asked. Half of course gets cancelled, m gets cancelled, omega square gets cancelled. Come on, simplify the rest. A square minus y square is equal to y square. Take this y square that side. 2y square is equal to a square. In other words, y square is equal to a square by 2, and what we want is y, which now is going to be a by root 2 as such. Same question has been repeatedly asked 2 times earlier at different EAMCET papers. So one of the excellent questions over here, at what displacement the value of kinetic energy and potential energy of the particle in SHM are going to be equal numerically. In this problem, of course, amplitude is given as a capital A. Therefore, your option automatically will be A by capital A by root 2. The second option is the correct option for us. That is the question number 18. Now look at the next number, please. Question number 19. A particle executing SHM has kinetic energy K0 cos square omega t. The maximum value of its potential energy and its total energy from the equation are respectively how much? One should understand the language carefully here, the terminology in fact. If I say total energy of a particle in SHM, that is, of course, we write half m omega square a square. And secondly, what is the maximum kinetic energy? Maximum kinetic energy means it is understood potential energy is minimum. Minimum value means 0. So maximum kinetic energy also will have the same equation, half m omega square a square. Exactly in the same manner, what is maximum potential energy? Potential energy maximum means the kinetic energy is 0 obviously. Then once again you will be getting half m omega square a square. Look at these 3 wordings carefully. Kinetic energy maximum whether they ask you, or potential energy maximum whether they ask you, or total energy of the particle they ask you, all the 3 are having the same formula, half m omega square a square. Now you see the given equation now, kinetic energy is equal to K0 into cos square omega t, that is the formula. In fact, what is this K0 to be called? It is called maximum kinetic energy. When this is called maximum kinetic energy, can't you just call the same as maximum potential energy also? Can't you just call the same as total energy, that value also? That means whether you call it total energy or maximum potential energy or maximum kinetic energy, it is equal to K0 only. Look at the question now that is asked. Its potential energy, which value? Maximum value. And total energy. What is maximum potential energy? K0. What is total energy again? K0. So maximum potential energy is also K0 in this particular case, and the potential energy maximum also is K0. So K0 and K0 are the corresponding values for us. So no need for you to calculate anything. It's simply identification that matters. So what is the correct option there? The third option is the correct one. K0 and K0. These 2 are the correct values what have been given over there. Third option is correct option. Now let us take the next number, that is problem number 20. A particle of mass m executes SHM with amplitude a and frequency f. The average kinetic energy during its motion from the position of equilibrium to the end is. Equilibrium means starting from mean position of rest. That mean position itself is equilibrium position, we can say. Suppose if a pendulum is oscillating, like this is equilibrium position and this is extreme position. Now the question here is average kinetic energy. You know very well, at extreme position kinetic energy is minimum and its value will be 0 because the body stops virtually there. And of course while coming back, kinetic energy is going to be maximum. Just now I have given you what is the formula for maximum kinetic energy, half m omega square a square. What is minimum kinetic energy? 0. His question is, between the mean position and extreme position, what is the average value of kinetic energy? Average value of kinetic energy means what? This plus this by 2. Half m omega square a square plus 0 by 2. Is it not simply speaking 1 by 4 m omega square a square by formula, please? But what are the values he has given? You substitute there. Mass is given m, amplitude is given a, but omega has not been given in omega terminology. So what we should write now? Half ma square till that extent, okay. Omega square can be written as 4 pi square f square. Why f square? You can directly understand over here. This is now 1 by 4 we have to take, because here we have 1 by 4 ma square into 4 pi square f square, because omega is 2 pi f, f being the frequency. Now f4 gets cancelled. What is now left over? You see, ma square pi square f square. Look at the option, which one that is tallied with this number, please. You will be finding pi square m a square f square. The second option is going to be exactly tallying with the option what we have got, or the answer what we have got for 20th question. Now look at the next number, that is question number 21. A wonderful concept which is of course directly related to center of mass concept. A linked up model theoretical question, I should say. The bob of a simple pendulum is a spherical hollow ball filled with water. A plugged small hole near the bottom of the oscillating bob gets suddenly unplugged. Then the time period of oscillating pendulum will be how much? Like what happens to it? Let us discuss the concept carefully. This is a pendulum, say, with a hollow bob. There is a small hole that is made at the bottom, say like this. A very small hole, of course. It is now filled with water according to the question that has been given. In general, when you put a plug over here to cover this hole, and if you start making this one oscillated to and fro with respect to the mean position of rest, that is, it is now in simple harmonic motion. Now what happens? This being the center of mass of the system, from the point of suspension to this particular point, the length whatever we are taking up here is called length of the pendulum. But all of you know very well, time period of an oscillating pendulum is 2 pi root L by G, the formula. Now what is this L means? Right from the point of suspension to the center of mass of this particular bob, whatever the distance we people are getting, that itself is called L. Fine. Very good. But the point here is, when you have all of a sudden taken out this particular plug, it has been unplugged, he is talking. When it is unplugged, like, what is it you are finding? Slowly and steadily, water gradually comes down. It comes out of the system. When it is coming out of the system, can't you understand that the level of water is gradually decreasing, please? When the level of the water is gradually decreasing, more mass will be concentrated towards the downward direction. When more mass is concentrated towards the downward direction, the center of mass point will gradually be shifted downward. When center of mass is shifted downward, can't you understand the length of that oscillating pendulum is gradually increasing now? When length increases, automatically you can understand time period also increases. Fine, but how long that length increases? Till the entire water goes out. Suppose water has come out, then is it not a hollow spherical body? When you find a hollow spherical body, won't you find once again center of mass going back to its normalcy, please? That means initially length is increasing, therefore time period is increasing. After the entire water has come out of the system, once again the point goes back to normalcy, that is center of mass comes back to its original position. Thereby, first time period increases and then it decreases. That means what you should understand, as long as the water is pouring out of the system, gradually time period increases. When once water has totally gone out and the center of mass is coming back to normalcy like, then automatically you can understand the time period is going to be reduced over there. So if you look at those four options carefully, remains unchanged, first option, remains unchanged does not arise at all because length is a variable. When length is a variable, automatically time period is supposed to be varied, there is no other go. Second option, if you look at, becomes infinity. That is possible only if the system is in some space, like when G is absent totally or G is 0 totally, then only time period becomes infinity, otherwise it's not possible. See the third one, first decreases and then increases. It is ridiculous because length is increasing first, then automatically time period should be increased, then first it increases and then it decreases. The fourth option that's going to be correct over there, please. So for 21st question, the option is correct, option is the fourth one. Just look at the last number over there. I hope that is the next question over there. That is 22nd. If the maximum speed of a particle in SHM is V maximum, then its average speed will be how much? Average speed, underline that word, not average velocity. Average speed, okay, average speed, if I write that one as V like this, it is total distance travelled divided by total time taken. That is actually the concept. And of course we know what is maximum velocity. It is A omega. Now here the question is, average speed we want in how many oscillations? Of course A omega can be written as A into 2 pi by T. Like this, that is the concept. Now maximum speed of a particle in SHM is V maximum, then its average speed will be how much? Average speed means what exactly is the case over there? It is in fact twice the value of V maximum by the value of pi. What for you people can understand, please? If you take up V maximum, right, A by T, what is that A by T here? Total distance travelled is 4A in one oscillation. Time taken is going to be T. Then what can we write now? A by T times 4 will now be the average velocity. What is A by T from this particular equation, please? A by T is equal to V maximum by 2 pi. This is the corresponding equation. Now substituting this one over there, average velocity will now be 4 times A by T. What is that A by T here? V maximum by 2 pi. Now of course 2 cancels here twice. So what is left over? Twice V maximum by pi. This is the corresponding value for average speed. But one thing you should understand, suppose the same question has been asked with a slight difference. Average velocity if they ask, total displacement by total time. In one complete oscillation, total displacement will be 0. Therefore, you need not calculate this value. Average velocity can be taken as 0 simply. But if you look at this particular chapter, simple harmonic motion, ahead we are having some of the major and important applications of this topic. One is a simple pendulum and its applications over there, and second one is a loaded and oscillated spring. These two concepts and about different other concepts of simple harmonic motion in general, we are going to take up in the next lesson. That is what actually we are taking up here. So just go through those formulae also, and I hope all of you might have understood what we people have discussed today. In the same manner, we shall take up some more applications in the next class based on simple pendulum and this loaded spring and its applications as such. Right? Thank you.